Fourier. So this was it was a person who introduced the Fourier series. His name was Joseph. They have kept the name John Baptist Joseph Fourier. Okay, so in this Fourier series, it is represents a time domain signal into the frequency domain signal. So what I said before is analysis of signal. So we have a time domain, we have a time domain signal. We are going to convert into the frequency domain. So as we have said, the Fourier series are going to do that only. It is a process. It represents the time domain signal x of t. So note this one. This is very important. It represents the time domain signal x of t into the frequency domain x of w. That is x of omega, not w. Sorry, it is an omega. So that means the time domain is converted into the frequency domain. If we convert, what is the use of, you may ask, what is the use of converting this one? Yes, it have a uses, because taking directly the time domain, it is very difficult to analyze. If we convert it into different frequency signal, then we can easily analyze it. So you may think that if I giving an input signal with a square, means whether I will get it back the same signal. Yes, sure, you can get it, because we are taking this square signal. That means your square input, that means the time domain, we are going to split up into a different frequency of signal to obtain a original signal. So that is what we are going to do it in the Fourier series, and it is representation of periodic signal in terms of infinite sum of sines and cosines. So what we are going to do is, this is a time domain signal, and later on I will explain you in that diagram. So if you have a square signal, right? If you have a square signal, means what we are going to do is, we are going to convert n number of, that means n number of sinusoidal waves to obtain our original square signal. This is what we are going to do it in the Fourier series. In this Fourier series, what is the thing is, in this Fourier series there are two types. One is a trigonometric Fourier series, another one is an exponential Fourier series. So these are both have a formulas. So we have two types in our university exam. In the Fourier series, they may ask a trigonometric Fourier series or exponential Fourier series, and the trigonometric Fourier series is very, very important in our Fourier series. They may ask in a 13 mark. So what they will give some square wave, or they will give you some triangular wave, or they will give some types of waves to obtain the original signal or obtain some signals. This is called as an Fourier series. So as I said, what I said is the time domain is converted into frequency domain. So I am giving an input, right? So I am giving an input. I have drawn only the example. I didn't mention any the time, the x-axis, y-axis and all. I have just drawn the. I'm like here to explain you how the signal is processing. So for example, I am giving the square signal. So what I said, we are going to take a x of t, that means a continuous time signal, we are going to convert it into x of omega, that means a frequency signal. So what happened is, instead of this square signal, I'm going to take n number of sinusoidal. See, so there is a difference. See, this is n number. So this is like bigger, this is little big smaller. Then compared to here, this is very smaller, and this is compared to very smaller. What is the thing is, we are going to add each and every signal. That means, see, for example, if I add both the signal, I will get this signal. So when I add this signal with this signal, so what happened is, I will get this type of signal. When I add both the signal, I will get to the original signal. So this is how we are getting the frequency time. We are getting the original sine square. So see, we have given the input as a square. So at the end we got it as a square wave. So what is the in between we have did is, we have added the n number of sinusoidals. So the next picture I can show you. I will show you here. So see, this is a sinusoidal wave. So one by one, if I add it, I will get it the original square signal. So this is a square signal. I have added n number of sinusoidal wave from this point of view. From this point of view, if you see, means you will get it the output like this is frequency spectrum. So we are going to split up the signal like in the frequency spectrum. So each and every sinusoidal have an output. Finally we will get it in the output as as an we can now get an output as an square wave. So in this if you view like this is a frequency domain, and here you